Hi, Anshu. How you doing? Good to see you.
Hey Neil, how's it going?
Great, thanks. Thanks for joining today. Just for the audience out there, Anshu and I have known each other for almost a year now. We've been working together on, a couple different initiatives, and she's a data science expert. So I was excited to talk to her about all the new stuff going on with GPTs and large language models and see what a data scientist has to say about those things. So thanks for joining.
Thanks for having me. Really excited to talk about this. There's so much going on, and every week, every day, things are changing. So hopefully, I can give you a good picture or a good lay of the land to start.
Yeah, this is perfect. Yeah, I have a podcast I listen to that's the AI breakdown. It's a daily breakdown. It's crazy how much news there is around those. So why don't you tell us a little bit about your background first, and then we'll kind of dive in and see if we can translate from a data scientist down to a layperson like me, how these things can apply in the workforce, in kind of broader consumer life, and what else we could maybe think about in the future of how to apply them going forward. So love to hear about
Yeah,
you.
thanks. Yeah, and I'm currently serving as Chief Data Science Officer over at a company called Hanger, which is a VC and startup studio for companies that are focused on the public sector and technology. So kind of like a tech for good focus. I've been there a couple years, and prior to that, in terms of my work experience, I've been running data science and BI teams for 10 to 15 years. I started the data science team over at ZocDoc and built out data science and BI at Vettery. I am, like a lot of data scientists, a recovering academic. So I have a PhD in computational biology from Columbia, and I have my undergrad in computer science from MIT. I've been actually for my master's thesis at MIT, I did a lot of neural network work with backpropagation and developing some of those algorithms. And, it's been, just to dive in a little bit, a lot of the machine learning world had been focused on more statistical algorithms. And I think, the rise of uh, like CNNs and speech recognition, image recognition, and sort of generative language apps is sort of like, especially in the last year, has been a total game changer. So we're all adjusting.
No, yeah, no kidding. So super awesome pedigree. That's impressive. Nowhere near matching that, but let's talk about that. Like there seems to be a little bit of a gap between the scientists that develop the models and how long they've been using them, leveraging them. And more recently, let's say the last 12 to 18 months, the general population getting more and more access to large language models through GPTs. So tell me a little bit about like how you leveraged them in the past and now that bridge to more access and how people are using them today and your thoughts on that front.
Yeah, it's really, it's really a great question. So I mean, the concept of neural networks and deep learning has sort of been around, maybe as early as the 40s, but then really got some traction, I want to say in the 60s, with the concept of the perceptron and thinking about, kind of modeling a brain and what that could mean for computation. And there's been sort of research ongoing in this area for, since then. And in the 80s is when you really had maybe the first big pushes towards developing successful neural networks with the idea of backpropagation. And then in, I would say the 90s, you had still a fair amount of research and people were pushing forward. I think especially the idea of like CNNs, convolutional neural networks for like text recognition, that gained a lot of traction and production level use. But what you saw in the early 2000s was like, oh, it kind of felt like a slowdown. It was like, okay, neural networks, that was cool. And, and it kind of like, for image recognition, that's great for some of that. And for speech recognition, but it just seemed like, okay, like that's where that lands. What you saw then is like in the early 2000s, you did see speech recognition with things like Siri and all the tools that we use for speech recognition. Same for images and all the tools that we have there. And that was really, and the images were really sort of like the first famous huge neural networks. So like you're thinking about AlexNet, ResNet, these were like, took months, like kind of on the order of a month to train. And you'd be able to recognize images. Now, in the last like several years since then, people have been thinking about the problem of NLP and sort of generative language. I think around 2015 or 2016 is when this like seminal paper came out. This guy Vaswani wrote this paper called "Attention is All You Need," and introduced the idea of a transformer, which is a type of neural network, and from there, what's been so interesting, the idea, and that introduced the concept of memory, really, in neural networks that existed in recurrent neural nets and some of the other models, but this transformer model was kind of, the idea was like really transformative in terms of saying like, hey, we can really capture memory and use that to generate a sequence. So that idea was introduced by Google, and then ChatGPT or OpenAI came in and they kind of took that idea and ran with it, with this idea of a GPT, a generative pre-trained transformer network. Now that it's out, came out, early last year, people like, I think as opposed to some of the other developments in deep learning and neural network, which is like, hey, it's an output and you use it. This feels like a tool that, people can use to create, not just decipher. And so that is a game changer. And people want to know how to use this, right? How to build these, how to use these. And I think so this is a long-winded answer, but to your sort of question, almost all the advancements, in contrast to some of the other things, other technologies where you'll see, developments, in academics or startups or things like that, it's like, you have to have a lot of money to build these networks. They are built in-house. They take, I think some estimates like over $1 billion to create one, transformer network. And so a lot of the advancements have come out of places like Google, like Meta, Microsoft, obviously. And so, yeah, I think all of these creators of these transformer networks are creating options and ways for people to be able to use them. And you're thinking about prompt engineering, RAGs, model fine-tuning. But I do think in terms of an industry trend, you will start to see other conglomerates come together to say, create networks for academia, things like that.
That's awesome. There's a lot there. So that was a great background. And you were talking about, some acronyms that some of us don't really understand super well. So you kind of touched on what they are, but what does a perceptron and back propagation mean? Just out of one question.
Perceptron. So like I love this a metaphor. So it's like, one of the things about neural network and deep learning is like, it's modeled off of, the idea is like, we're making a brain, right? And so I follow Jan LeCun, who's definitely like one of the godfathers of deep learning. And he's like, we don't know how we kind of know how to do it, but we don't know exactly know why or how it works, right? And so it's like thinking about birds to airplanes is like brains to neural networks, right?
Gotcha.
And so,
That helps.
and
Thank you.
so the idea of the perceptron was really like the basic core idea, which is like, okay, if I were to model a brain, like, how do I do it? What's a neuron? And so the perceptron is sort of the CS computational version of a neuron, and it's really saying like, hey, this neuron gets this number of inputs, it processes them. It's really just a linear equation, and then it gives you an output. And when you build a neural network, it's layers of perceptrons. So when people say, hey, this network is 50 layers, 50 hidden layers, they're saying, oh, it's 50 layers of perceptrons. Now, if you think of each perceptron as a linear equation, and then there's some processing that comes after it, you have weight, like you think a linear equation would be like, beta x naught plus beta x1 plus beta x2 equals something, right? And so you need to figure out what those betas are. And so those are, you need to figure out what those parameters are. So backpropagation is a technique to help you derive those parameters. And backpropagation is like a practical application of the chain rule. So if you remember, so this is a lot of linear algebra and matrix work, but it's math. It's basically, that's the incredible thing. It's like, we're trying to mimic a brain and having some success, or people, not me, but people are doing that, and it all comes down to math.
Yeah, that's fascinating. So you were a computer scientist and then became a data scientist, and you've used both of those, and obviously they're very math-based, algorithm-based in both cases. But is it nice to have that background of sort of the computer science and how to actually write the code that allows the human to interface with the algorithms and the math and the data itself in these large models?
Is the question like, do you need to know this to use this?
Well, yeah, like how do you actually translate it from math to something practical?
Right. So what I think is like, you don't, everyone's using it, so you definitely don't need to understand, what's happening underneath the hood to use it. But of course, the more you understand it, the more you can probably meld it to what you want. You can get what you want out of it. So it's the idea of like, doing something very empirical, experimentation based, and just saying like, hey, my inputs generate these outputs, so I don't need to understand what's happening behind. Or like, I know that the model was trained in such and such way, so I can sort of prompt it and use it that way. Yeah, and I think the math is so complicated. I would say I don't understand it, but conceptually, I think anybody could pick up the concepts.
Gotcha. Yeah, that's fascinating, because I was listening last week to on another podcast, one of the guys from OpenAI talking about, just sentiment. You can actually be nice to the model and it's going to change the response and perhaps improve it. So it's pretty fascinating that, depending on which model you're interacting with on how it might respond to your query or your prompt. So, So talk a little bit about, OpenAI's ChatGPT versus Google Gemini, or any of the other ones that you're familiar with, and some of the use cases you leverage on them today.
Yeah. So in terms of like the actual models that are out there, the big one, there's getting to be a lot. There's like a crowdsourced leaderboard that I follow to see what people really are liking. But the ones that I've been kind of following a lot, GPT, which is now at GPT-4, Google Gemini, and, of course, baked into Microsoft, Google Gemini, which Pro, which is at 1.5. But each one of these has like multiple kind of tiers of options. So ChatGPT, Google Gemini, Meta's got Llama, and Mistral, the European-based one. But there's tons of others. There's Claude. There's Hugging Face. Let me see. There's like so many. I'm going to pop over here just to take a quick look.
No, it's fake. I was just going to ask you, can you tell us what's the name of the leaderboard, and how could other people kind of take a look at maybe which ones work most effectively? Because I've heard some things about image generation being better in certain platforms than others, and the language or the text-based prompts being better, depending on which one you're using. So
it's a bit of a race at this point in time. It's a bit of a race. It's like changing. It's such a dynamic situation because people are releasing things every day. So OpenAI and Google, like those are closed. Like those are very proprietary. They are not saying too much about how they've, they're giving you high level details, but they aren't really opening up the hood too much. That's what's nice about Meta and Mistral. Those are both like open sourced models. So theoretically, if you had, $1 billion, you could just like pull that code down and make your own. Or you can pull those models and do the fine tuning on them. So yeah, I mean, those are the big ones that I followed. The chat, the crowdsourced leaderboard that I am using, I'll send you the link, but it is called chat.lmsys.org. And you can pop into it right there, and you can see it's got sort of like the top 70-ish models, and top of the list, GPT-4, followed by Claude, followed by Gemini.
That's fascinating. I didn't even know that was out there. I would just keep hearing, like, through, listening and trying to stay up to speed with it. And what are my friends doing? How are they using it? That kind of stuff.
It feels a little like it's like knowing the hottest, coolest new thing or something. Like
right.
Claude just came out with it. I think this is like within the last week or 2 weeks that this is their latest release that everybody's using, and it's from Anthropic. Yeah.
Cool. So let's talk about your applications. I put something out there just a couple weeks ago talking about my use cases. So I've used it to do like to summarize a transcript, and I've used it to help with writing. I've used it to build business cases, to polish some positioning statements. I don't remember all the examples, but give me some examples of how you leverage those tools, based on your kind of work product or your background.
Yeah, and I'm in many ways in the same sort of boat with usage, but I can talk to some other types of use cases as well. But from a work perspective, just the same as you, language polish is huge. So I've been using it to help with like some grant applications, things like that. I've heard it's been used for generating like questions for interviews or questions for games, things like that. It's a content generator. So, if you're thinking about, developing content for your webpage, if you want to say, hey, I'm building a product focused in the fire tech domain, and I want to generate a bunch of like marketing landing pages to help, to get people to draw people to my site, and I don't want to hire a bunch of people to go and do that. You can use I've heard that use case has been really successful. The other big thing is coding. People, I've been using it. I haven't been using it super extensively to sort of write large scale applications, but as I'm coding, I will, pop things in there to get some suggestions to say like, hey, how can write me a piece of code that does X, Y, or Z. And that's been a really important application as well. I think those are a lot of the big ones. I think, but I do want to mention the sort of usages that are a little more advanced, which are things like with ChatGPT, they call them the RAG models, the retrieval automated generation. So that's where you can really not just do some prompt engineering, but say to an LLM, here's a core base of data that we want you to reference as we ask you these questions. And so it goes beyond the text that just ChatGPT, that an LLM itself was trained on. So I think that is something people will use for generating their kind of proprietary content. If you have specific financial data or any of your product data, or if you want to analyze your company's finances, any of those things.
That's awesome. That's fascinating. So let's switch gears then and talk a little bit about sort of ethical concerns and if you're going to be using it for private use, if you're trying to keep intellectual property safe, what does that look like compared to these kind of publicly accessible GPTs, especially if you're sharing data? Talk to me a little bit about risk and ethics and how the data could potentially be used.
Yeah, I mean, this is this is a hot and probably controversial topic. I think you see OpenAI has sort of taken the position that they are going, to, release things and take the risk, with whatever disclaimers they can put out there. But then you see the immediate feedback. I mean, there's been several cases, right? Like the image generation of like Nazis that were inappropriate, and they do a lot of and they come in right away to kind of like put blockers in. I don't really, what's the implementation of that? I don't know. We know that they, each one of these LLMs probably has, once the transformer's been pre-trained, they do month or 2 months of fine tuning to kind of teach it to say the right things. And I'm guessing there may be a layer but that's a guess, to sort of say like, hey, this is like a fixed guardrail. But so there's the ethics in terms of what it's releasing, into the world. But I think, this is, not to get too philosophical, but kind of fundamentally capitalistic society, so that, people will push the boundaries and are willing to take those risks. And then there's the other sort of ethical considerations of like, what does this mean for humanity? Like, will this replace all of our jobs and things like that?
Yeah.
And I think like, traditionally speaking, technology tends to shift labor markets. If we were to think about 100 years ago, we would say, 80% of all of us were, farmers, and now that's not true, and labor markets shift. But this is pretty, and as far as I can see, I feel like it's really helping a lot of small businesses be able to kind of like execute at scale in a way that they couldn't before. But, the next few years are going to be really critical. we don't know what this is going to look like. And I think it's really important to have these conversations, from our, science and technology policy people and ethicists that can sort of step in and help guide this. I think that's really critical. I know that's not my expertise, so yeah.
Yeah, that's pretty interesting, though. It kind of reminds me of the web and wikis when they first came out. People were like, well, is it truth? Are we publishing truth, or is this just general information available now that people are just pushing out there? And then you have your media outlets, who controls them, what's the messaging on them, and what kind of bias is there built in. And I'm certain that holds true with these models as well. So you just have to, do you have to be sort of use your own intuitive thinking in your brain to say, I'm a little skeptical about that response. Let's double check this and make sure that, it's an accurate response, or the data or information shared is accurate.
Yeah, I think I mean it's like, right, you have to kind of like there were all those articles when when ChatGPT first came out about the hallucinations, or convincing people to do X, Y, or Z like terrible thing, and like and so it's not, it's generative. It is not a truth. It's not, not necessarily a truth teller, like, and there were even the examples where it was like, doing math incorrectly and things like that. I mean, just, I think this is where having, like knowing that, like, hey, this is trained on a bunch of old data. So it's going to lag, especially for kind of, I know, like DEI types of things. Like, it's corpus is older data, so it is not, it's not leading, it's kind of lagging on based on the information that it's been trained on. Then yeah, I mean, I don't ever take a result from an LLM and treat it as like the absolute truth. Like, it's like, I think about it as like a language creator, and is it, and it could summarize, searches and things like that. But yeah, it is pretty incredible, some of the things that it can do, but you definitely have to sort of keep your critical eye on it.
Cool. All right, so let's close out talking about like the future. Where do you see this going? Like, do you have a sense, looking ahead, of next steps? I mean, it's been crazy this last 12 to 18 months, how fast and rapid, and each model now is kind of fighting for market share and releasing cool new updates on a regular basis. So this will likely keep going. Do you think this pace will continue for a long, extended period of time, and we'll see some clear leaders emerge? We've already got one or two out there, obviously, but what is your thought on looking ahead?
I think this is just the beginning, and in some ways I feel like, like I said, it's like every week and day there's something new, and when you and it's been very, very powerful. We just saw Sora's come out with the text to video generation, and even though it's not released to the public, it's, what we see is really impressive. I think we are in a new era. I mean, this is like, history being created on a day. We're just watching it sort of be created on a daily basis, which is wild. Again, like coming back to metaphors and analogs, like, I was just recently at Penn with some of my family, and that is like, where the first computer was, like ENIAC, and it's a giant computer in not a giant room, in a big room. And, it could just do a handful of tasks. And, here we are 60, 70 years later. And, that's probably like we've got supercomputing, machines at our fingertips. And I think very similarly, the idea here was like, hey, we're going to make a brain. And right now it costs $1 billion and it takes 6 months to a year. But, in 50 or 60 years, like, that brain might live in your pocket, or be something that you kind of like hold in your hand and use as a reference that's with you all the time. I think, like, looking more short term, I think the applications for, video and text and images, I mean, are kind of have huge potential. And I think probably the very next thing you're going to see us get into is robots and robotics.
That's very cool. Yeah, you were talking and supercomputers, and I've heard the terminology quantum computing thrown around out there. So, like, I was actually having a little debate with a technical friend of mine about not really a debate, but like, how do you use quantum computing and sort of these models and GPTs, and you just talked about it. You're going to see the ability for people to have incredible compute power in their pockets within a relatively short period of time. I don't know what that timetable looks like, and everyone that uses mobile phones today is probably, just in awe of what you're able to have at your fingertips. But what are you thinking in 5 or 10 years that means in terms of, applications for using that type of compute power versus what we might have today?
5 to 10 years, like, I mean, I definitely think, like all the robots and the autonomous, driving, I think that type of stuff will be there. And that's like, that's deep learning generally. That's maybe not LLM specifically. And then, but I think, with LLMs, I think they're going to be assistants for coding. People have talked a lot about the entertainment industry. What is that going to look like? I think that's a big black box. There's a lot of probably ethics questions around that. So, but like probably lots of wide application for it. Yeah, I think. I mean, I'd be really, some specific areas I'd really like to see it in are like healthcare, like access to incredible healthcare at your fingertips. I think that could be like really incredible. Education, of course. I mean, I feel like people have already seen those applications where, like I think Gemini has the demo where it's like you can put in your like physics like homework, like a PDF, and it can like read it, and then it can read your handwriting, and it can say like, hey, this is the answer to the problem, and here's where you got it, and here's where you didn't get it. So I think, and and I think that's a great one because like we've had like YouTube, we've been learning with YouTube videos, for the last like 10 or 15 years. And it hasn't meant, oh, we don't have teachers in schools or anything like that.
Right.
It's like a teaching aid, and it helps. It has really helped a lot. So I think education and healthcare would be like 2 great application areas.
Oh, that's perfect. And totally agree. That was interesting. I was watching the Oscars last night, and they were talking about, the reason that they went on strike or whatever last summer, the writers and actors, was because of the concern about, somebody just replacing them, a computer generated imaging just replacing them. And they negotiated a contract to ensure that wouldn't happen for, certain types of films or whatever it is. I don't know the details around it, but that was pretty fascinating.
Yeah.
That they were already looking ahead and worried about, how this is going to look in just a few years because of how fast this is developing.
Yeah. And I think that was a smart sort of move. And but at the same time, we have, I don't know how things are going to sort of evolve. Like it is really crazy. So.
Well, this has been awesome. Thank you so much for your time. This is great. And if people want to reach out to you directly, Anshu, what's the best way to do that? Is it via email, or what's your online presence you're willing to give out to the few people that might watch this and want to talk to you?
I'll give my email out, but how about you can find me on LinkedIn?
Okay, perfect. Yeah. Perfect. So Anshu, Anshu, Sinha, Sinha.
What's right? Me.
Sorry, go ahead.
Yeah, that's right. That's me. And yeah. And this is what I look like. So.
Yes, so you heard where she graduated from. So Columbia, MIT, and you should be able to track her down if you want to connect with Anshu and further the conversation or ask any questions. So thank you so much for your time. And this has been great. Appreciate it.
Thank you. This was great. Thanks, Neil.